Okay, good morning everyone. Great to be here. This morning, I'll be talking about how, as geotechnical engineering family, we can deal with two emerging and grand challenges of climate change and environmental justice. First, is it real that we have to deal with climate change? Let's look at some facts. This is the most recent IPCC report, which was just published in February 2022. The first fact is alarming. The Earth is warmer than it has been over 125,000 years. This is a fact. There have been worsening pattern of extreme events all around the world using recorded data and also projected future patterns. So we see consistent pattern of worsening extreme events. Part of that is related to climate change, land use, land cover changes, and urbanization are other factors playing in this worsening patterns of extreme events. Adaptation and mitigation, two urgent actions that we need to take, and rapidly closing window for both two action items that we have to take. Let's look at some numbers again. This chart, you see the number and the cost of billion-dollar disasters in the United States. Each weather and climate event costing more than $1 billion loss. As you can see from the data since 1980 till 2021, we have been having an increasing number of billion-dollar disasters. Just to give you a perspective, the average for 1980 till 2021 has been $7.4 billion disasters. This annual average has increased to 17.2 events for the past 5 years. As I said, climate change is main factor, but we have had land use, land cover changes, urbanization, and higher exposure to those extreme events causing to those increasing or rising billion-dollar disasters. Does it matter for us in geotech? When I talk about climate change in the geotechnical engineering community, you know, people say, oh, that's good. Sometimes just good for you. Is it something just good for those who work on those areas? My short answer is no. It's for everyone. It's a daily thing that we have to deal with that. In this figure, you see a number of different processes that climate extremes or climatic processes can impact on earthen structures. If we have more extreme rainfalls, we all know that that can increase pore water pressure. If we have more severe drought, it's a recipe for more desiccation cracks. It can cause more erosion. If we have more flooding, we have to revisit our design guideline and maintenance guideline for flood protection systems in the country. So in all those, you see that we have changes in two main factors. Supply and demands. Demands are hydraulic loading, thermal loading, or mechanical loadings imposed by those extreme events. We have to adjust to those changes in our demands. And in terms of supply, we have to revisit what we can get out of soil, shear strength, compressibility, the impact of those changes on shear strength, compressibility of the soils. Just recently, we were talking about a new area, how we can better quantify the impact of drought on earthen structures. Just think about it. It's not very intuitive. When you say impact of rainfall, everybody can imagine we will have more landslide. But the impact of drought on earthen structures, to give you a number, drought can cause deep desiccation crack as deep as 20 meters. Those numbers are recorded in levees. When you have deeper cracks, those will serve as pathway for next rainfalls and water. Getting water into the structure can cause more failure, more severe failures. What can we do? There are two action items, mitigation and adaptation. Before going through the list, few points. Think differently, act urgently. This is not our comfort zone. We have to get out of our comfort zone and start thinking differently. How we can come up with new ideas, creative ideas, to contribute to those grand challenges. I listed a few items under mitigation and adaptations. In terms of mitigation, carbon should be a key part of every conversation that we have. For any design, for any analysis, not only we have to look at the output, we have to also look at outcome and impact, carbon footprint. Explore more sustainable ways or sustainable materials with lower carbon footprint. And also engineering with nature. Explore ways that we can deal better with nature. Those 3 items are some suggestions in terms of how we can contribute to mitigation to prevent or reduce CO2 emission to atmosphere. At the same time, we have to think about adaptation measures. What are adaptation measures? How can we adapt to this changing climate? We already have, in average, 60-year-old levee systems in the country. They were built 7 years ago, 6 years ago. Most of them were built over centuries ago by farmers, settlers, for a very different purpose. They were not supposed to be critical infrastructure systems. But over the time, the role evolved. They became a critical component of the nation's infrastructure systems. They were not designed with any rigorous engineering design guideline, most of them. So how should we prepare them? How should we adapt those old infrastructure systems to this changing climate? I listed a few items. First thing first, we have to better understand and quantify the change of climate impact on the pattern of extreme events. For us, those are loading conditions, flood patterns, extreme precipitation, drought, combination of all those. The notion of compound event, cascading events, receiving more and more attention. Do not ignore the interplay interaction among those. So first thing, we have to quantify the impact of climate change on the frequency and intensity of those extreme events. This is something that we need to work with climate scientists, hydroclimatologists to understand. Then we have to quantify processes and loads by those climate-adjusted extremes on Earth and infrastructure. The next step is we have to quantify, evaluate the impact on short-term and long-term behavior of geotechnical infrastructures. To adopt, we need to develop and implement adaptation and maintenance strategies. Of course, we cannot redesign and rebuild the whole nation's infrastructure. So there has been a growing interest to shift toward more soft adaptation measures. Think about how we can adopt existing infrastructure without the need with reinventing the wheel, without the need to rebuilding the whole infrastructure systems. So those are some just thinking ideas to see what we can do. What are the challenges for us in geotech to deal with mitigation and adaptations? And those are some of my personal experiences going through this process, learning experience for myself. This was not my comfort zone. That was not my sheer strength calculation. I had to take a lot of 101 type of classes to learn about climate science, to learn about RCP, learn about terminology, to search on Wikipedia or other resources to learn about them. So be ready to go outside your comfort zone. There are knowledge gaps in different areas. Yes, it's great to attend, presentations by climate scientists. It will be fascinating to see colorful maps. But then when you get into details, you see there is a large uncertainty, huge uncertainty and variability among climate projections. How can we deal with that huge uncertainty? They keep changing, they keep improving their climate models. But if I'm supposed to design an infrastructure today, I need to design it today. I cannot make change in my design 2 years from now. How to deal with this huge uncertainty? And because of climate change, because of urbanization, because of land use, land cover changes, there has been a growing interdependency among different infrastructure systems. So we no longer talk about one infrastructure system. We talk about a network of infrastructure system and interaction with human systems. Just consider that. Policy and regulations. There is no procedure in place. If you need to bring it to engineering practice, we need to have regulations. We need to have policies. We need to train our practitioners to do that. At the end, I use red font for that last item. How we can promote justice and equity for climate change adaptation. What do I mean? I give you a few numbers just to understand the extent of the problem. We are all excited about the infrastructure bill, yes? Everybody is so excited it will be a revolution in our infrastructure system. The total bill or the law is $1.2 billion, correct? And out of $1.2 billion, $550 million are allocated for rebuilding or strengthening our nation's infrastructure system, with the primary focus on climate adaptation and promoting environmental justice. So $550 million. A very recent study showed that our nation needs $27 trillion to just bring our nation's infrastructure to the state of good conditions without considering any climate change impact. 550, $27 trillion. If you do the math, we got 2% of what we needed. It's a great start, but remember the number, 2%. The question is, where should we spend this? How should we prioritize our infrastructure systems? As a part of this infrastructure bill, White House started this initiative called Justice 40. Justice 40 says that 40% of any federal investment should go to disadvantaged community. So remember that 2%, out of 2%, 40% of that 2% should go to disadvantaged communities. Not surprisingly, disadvantaged communities and historically underserved communities are paying the cost of climate change more than any other community. They had the least contribution to CO2 emissions, but they're paying the most, the highest cost of climate change. What is environmental justice? Environmental justice means fair treatment and meaningful involvement of all communities, people, regardless of their race, income, and sources of other factors. If we want to promote environmental justice, we have to prioritize areas that are in urgent need. We have to identify disadvantaged communities to allocate more resources. And a recent study showed that just for flood hazards, disadvantaged communities, historically underserved communities that are impacted by flood, 30% more than other communities. At this unequal impact of climate change will increase in future. So we need to develop a framework to get those historically underserved community, to listen to them, develop adaptation measures, share those knowledge and adaptation recommendation, make sure their voice is heard, and assess the risk. Assess the risk to those communities and other communities to make sure we can promote environmental justice in those communities. I try to keep it short. It's my first experience of PIT talk, but I just wanted to touch on some key points. Again, I would want to highlight one point. Let's treat climate change and environmental justice, regardless of coming from a red state or a blue state. Let's treat it as a human-centered, science-based engineering problem. Human-centered, science-based engineering problem. Thank you so much.